Welcome to the cloudonaut podcast. My name is Andreas and you are listening to volume 4 of the AWS-to-go series. So get started with AWS or broaden your knowledge while walking, biking, running, driving, or whenever you enjoy listening to podcasts. There are 3 things I want to highlight before we get started. First of all, the AWS-to-go series is based on our book Amazon Web Service in Action, published by Manning. And we are currently in the progress of writing the 3rd edition. Many chapters are already available for reading, so you should get your copy today and check the video description or the show notes for details. Second, AWS expertise is in high demand. So our partner Demicon, for example, is hiring a senior lead full-stack developer working remotely from somewhere in the EU. Your favorite technology stack should include JavaScript or TypeScript, Angular or React, and of course, a lot of AWS. And also our partner TechRaiser is hiring cloud consultants focusing on AWS and DevOps. So you should definitely apply when you like building with infrastructure as code, containers, continuous integration, and so on. Join TechRaiser in Hanover, Duisburg, Frankfurt, Hamburg, Munich, Vienna, Lisbon, and Lucerne. Again, for both Demicon and TechRaiser, check out the show notes / video description for details about the open positions and apply. And third, finally, I'm switching to you, Steffen. Steffen, welcome to the show. So this is our 4th recording of the AWS-to-go series. I'm so happy to have you aboard again. So Steffen, you are a web and front-end developer, so I promise you what we discussed today is definitely out of interest for you and should feel a lot more familiar to you already. So welcome to the show, Steffen.
Hi, everyone. Hi, Andreas. Thanks for having me again. I'm looking forward to this episode.
Perfect. So let's get started. The topic for today is infrastructure as code. And if you follow along, you can check out chapter 4 of our book, AWS in Action, the 3rd edition. Okay, so let's get started. So Steffen, when you hear the term infrastructure as code, do you have already a feeling or an idea of what all of this will be about? Have you ever heard of that term before, or do you have a basic understanding already?
Not really. How would I imagine infrastructure as a code is out of the blue, I would say it's code I can run in AWS, and this code executes or does any, it's a program basically I could run somewhere. So I don't know, for example, I could run a code which spins up an EC2 instance for me.
Mm-hmm. Yeah, so I think, that's a very good description already. So before we dive into the topic already, thank you for that. So so I think the thing I always start with when I explain programming against the AWS is, so the important thing about AWS is it's called Amazon Web Services. And web services means the idea behind all of that is that you can control all of the AWS services by calling a web service. So basically, over the web, so over the internet, you reach out to an interface. Typically, that's a REST interface, REST API. And by doing so, you can fully control the service. That means you can control all your cloud computing infrastructure by making calls to REST APIs. And that's, I think, the real powerful concept behind of AWS. And all the tools we will discuss today basically rely on the fact that there is an API for all those services. So it's true for 99% of all AWS services. And you can use them to program interactions with AWS instead of clicking through the management console, which is their graphical user interface. So that's what we will talk about today. So how to make use of that API, or maybe you could call it APIs because it's a lot of them for different services, and how to make use of that to automate your infrastructure. That's basically what this is all about. So the first thing I want to talk about, so now we have the understanding that there is an API for all of our services, for example, for starting a virtual machine with EC2 or for storing data with S3. And there are 3 different approaches that I want to go through today, Stefan. And the first one is called the command line interface. So Stefan, so have you ever programmed a shell script? Are you familiar with that?
A very small one.
Very small. Okay, that's fine. Because this is really for very, very, I would say it's for really basic things that you want to write into a short script. So the CLI, so the terminal, so you start the terminal on your machine and then you can use the command line interface already. So just in your, I don't know what you prefer, ZSH or I don't know, Bash or what have you. And you can basically use the CLI just to type in commands interactively. And I do that a lot in my day-to-day work. So I do that to, for example, launch what we will talk about later, CloudFormation stacks. I do that to copy data on S3. So for example, Stefan, one thing I always, and I told you how to do that already and you have done so. So this is the CLI to copy data to S3. You remember that? The AWS S3 sync command that I told that you've used to upload and download our video files. This is the command line interface that you have been using already. So that's the thing I'm talking here. And the CLI, so basically, I'm using it for 2 things. So first, I'm using it in my terminal when I just hack around and type stuff to get things working on AWS. And then the other area where I use it is basically when I have very basic functionality that I want to automate. And mostly that's when I need to automate a few things, for example, when an EC2 instance starts. Then I write a short shell script, and this shell script uses the CLI to, I don't know, create a DNS record or attach a volume, stuff like that. So just making a few API calls to AWS with the help of the CLI, and then bundling that in a bash script typically. So I'm really using that only for very simple scenarios because I'm not a very good shell script programmer. So I need a more advanced language when it gets more complicated. But for very basic things, I'm using that a lot. Yeah. So that's what the CLI is about. So I highly recommend. So after you got familiar with AWS and the management console, and as you have already now installed, Stefan, the CLI on your machine, so I really recommend checking out how that works and how to interact with AWS in this way, because you will learn a lot about the underlying APIs. And that's, I would say, important when you want to make sure to really learn the concepts, because the management console, the graphical user interface, hides a lot of the complexity. And sometimes it's more, it's really beneficial to know about the details, to know about the APIs that are lying underneath. So that is a recommendation from me to check out the CLI. And it makes some things, especially if you repeat a lot of tasks regularly, a lot more interesting.
That would have been also one of my first questions, what you would recommend for a beginner, if it's more the management console or a CLI. But I guess that's answer it. If you want to understand it, use the CLI. If you just want to do stuff without understanding, probably you're better with the management console.
So I would say I would start with the management console because it's the easiest way to get started. But then the second step, I'd use the CLI, for example, to get more familiar with the API. So I think start with the management console, but then after you did your first experiments, then use the CLI, for example, to dive into that. Okay, so and another story that I like to tell is, so that's actually how I learned AWS at the very beginning. So my first steps were, I was setting up an infrastructure by clicking through the management console. And then I realized, oh no, I need to do the same thing over and over again, because we had a production system and test systems, and I basically wanted to set up the whole infrastructure twice or multiple times actually to provide test environments. And so because I'm lazy, and also because I make a lot of mistakes when I need to click around, because I tend to forget hundreds of things, then the next step for me was to write a shell script and to automate at least parts of spinning up an infrastructure from scratch. And I was using the CLI to do so. But then, as I told you already, I'm not a very good, I don't know shell scripts very, very well. So I'm Googling a lot, I'm looking on Stack Overflow a lot, and then trying to build up my scripts. But obviously, for me, as I'm coming from, as I'm started as a software developer, it makes sense to use a programming language instead. So the next step that I did is I started to use one of the AWS SDKs. So nowadays there is an SDK for, I would say, almost every programming language out there, at least the more popular ones. So there's, of course, JavaScript, Java, Ruby, Python, Go, of course. And there's, of course, the Microsoft, the .NET world, the C# world, PHP. I don't know if I forgot anything, but there's really a lot of SDKs available, many of them maintained by AWS as well. This is really good start if you already know a programming language very well and are familiar with that, because it makes things a lot easier if you have a more complex programming language, at least for me. And so that's what the CDKs are all about. So Stefan, that's probably something you are familiar as a front-end developer in the JavaScript world. You know all those SDKs, or you call it frameworks, to build your stuff, and basically you learn the way you interact with the underlying API by calling functions and stuff like that. So that's very similar to
very common.
Yeah, and so it's very straightforward, easy to get started with. Personally, I'm a JavaScript Node.js guy, so I'm using the SDK for JavaScript, and a few maybe typical things I do with the AWS SDK. So one example, what I do a lot is when I program by using other AWS services. For example, when I program for our chatbot Marbot, then I use the SDK a lot to write data to DynamoDB or to read data from S3, all that stuff. So that's a very typical scenario for me. And also, for example, BucketAV, which is another product that I'm developing on. There we send messages to SQS. This is another API call that I do over by using the JavaScript SDK, stuff like that. So really to integrate with all those AWS services, I'm using the CDK a lot. So when I'm really programming and writing an application, then the SDK, is the obvious choice. The CDK, the Cloud Development Kit. Maybe let's get that elephant out of the room. So this is basically to program your infrastructure. That's something we will talk about in a few minutes. That's the other option available. So that's maybe the difference between the CLI, which is for interactive use in my terminal and for very simple bash scripts, and then the SDK is for more complex scenarios, and especially whenever I basically build by using AWS services. So it's not that much like spinning EC2 instances and stuff, but more like using a NoSQL database, using one of their messaging systems, stuff like that. Does that sound reasonable, or is that something that you get from my description?
I didn't understand the last part. like audio-wise.
Okay. Yeah, so a typical use case for the SDK is whenever I write a program, an application that makes use of AWS services. So think of a queuing system or a messaging system, sending emails, all that stuff. Whenever I do some more, I would say more complex scenarios, basically integrate multiple AWS services together with my source code, that's when I make use of the SDK.
Yeah, that sounds basically like I also use the CLI for smaller stuff to, as you already said, you're lazy and then you want to shorten things and just type in something small to just run multiple commands at once, and then using SDKs for more complex stuff. Yeah, that sounds very familiar.
Okay. Yeah, cool. So we already discussed two different approaches. So one is CLI, the other is the SDKs. And now we are diving into what I would really call descriptive infrastructure as code. So the problem is with both approaches that we discussed so far, that so imagine, Steffen, you want to spin up an AWS cloud infrastructure from scratch. So that means typically you need to create a lot of resources that depend on each other. I'd like to give you a few examples. So for example, you need to create a networking configuration with VPC. So that's the first step. Then after you did that, you can spin up an EC2 instance. But the EC2 instance, which is maybe running a web server, might need a database. So you need, before spinning up the EC2 instance, you need to spin up an RDS database instance. And to do so, you need a security group, which includes the firewall rules. So, what you get from that description is there is a lot of things that depend on each other. And basically, if you try to have a linear script with just commands after each other, you need to figure out, in which order do I need to execute these commands to make things work? And that can get quite complex. So that's one problem. Mm-hmm. And the second problem is, imagine now you're not spinning up the infrastructure from scratch, but maybe you use the script and you spin up the initial version of the infrastructure. But now you notice, I need to, add a new service or change something to the existing infrastructure. And then, so how do you do that? You need a second script for that, but you need to make sure that the state that you are coming from, that the commands basically make all those changes that are necessary. So what you need to do is you need to keep track of the current state of everything, and you need to remember what changes to apply, because otherwise, if you run the same script twice, or if you forgot to run the previous script in production, stuff like that, things will fail because the state that you basically rely on is not yet configured, for example. So it's really getting complex, especially for updating stuff. So that's actually what I learned myself. As I told you, I started with CLI, then I wrote something with SDK in Node. But then I realized, oh God, I cannot do that on my own. So basically, I need something else here because that's getting too crazy. Yeah. Or another good example, Steffen, is imagine you need to delete the whole infrastructure. So you want to remove all resources.
We talked about that already.
Yeah, we did when we discussed the WordPress example correctly. And so that's another thing. So if you use the CLI and the SDK, you need to write your delete script on your own. And you have the same problem. You need to delete things in the right order, otherwise it wouldn't work. So yeah, it's it's getting really complicated really fast. So that's I was struggling with that, and actually I didn't know about a solution for the problem. And luckily, someone, I don't remember exactly who it was, but someone told me, hey, you should check out CloudFormation. And I was, okay, yeah, let's have a look into CloudFormation. What is that? Sounds crazy. let's check it out. And I had a look into it. And basically, what is CloudFormation? So what's the difference? CloudFormation is a tool. I would call it an infrastructure as code tool. And what you do is think of it as a configuration file, a huge configuration file where you describe the state of the architecture or the state of the infrastructure that you want to achieve. So you're not describing the current state. You're not describing the steps that are needed to go from here to there. You're just describing the target state of your infrastructure. And then you're handing that over to CloudFormation. And what CloudFormation will do for you is it will basically calculate and analyze all the resources that you defined. It will analyze all the dependencies. It will compare it to the current state of the infrastructure. And then it will basically apply the changes that are needed to go from the current state to the target state. So when you start from scratch, it's simple. It just means create all those resources for me. But when you have something already in place, CloudFormation will just figure out, oh, I need to make a small modification here, a small modification there. I need to do that in that order, and so on. So basically, that's the job of the tool. We only define the target state. That's the beauty of it. And
so just did I get that? So I have one template. It's like one CloudFormation template, and no matter in which state my current instance is, I don't have to adjust anything. Like I just define I want to have this, and no matter if it's an already running instance or if it's a fresh one, I just can apply the same template. Did I get that right?
Yeah, and it's even going further. So, for example, let's say you define that you want to have a running virtual machine with a few specific, I don't know, instance type, security group, and so on. And now you decide, oh, I need to change the instance type, or I need to change the security group, the firewall rules. You're just modifying the template to the configuration file, and you're applying that template to the current state of the whole infrastructure. And then CloudFormation will figure out what it needs to do to achieve that. So it might be possible to just apply the change on the fly without any interruption. It might be necessary to spin up a new EC2 instance and delete the old one. So there are all of different things that might need to happen to achieve the new state, but CloudFormation will figure that out for you. So that's the interesting aspect here.
That's awesome.
Yes, it is.
That sounds very easy. Yeah.
Yeah, it actually is. So basically, and I want to mention that CloudFormation is not the only tool that is using the same principle. The other very popular choice is Terraform. And then there is a popular one, which is called the CDK, which is basically an abstraction layer on top of CloudFormation. So I would say that's the most popular options for doing infrastructure code in this declarative approach, as some call it. So basically, we declare our target state of our infrastructure, and the tool figures out everything else. And one side effect of this is that those tools are then also able to delete everything that they created, because they keep track of the resources and the state of them. And that's the interesting thing here. So maybe I want.
It's basically like. Sorry, it's basically like you already mentioned it. It's declarative. So it's basically using, in an abstract form, I would say, it works the same like MySQL for those who maybe can't imagine how this works. So I just tell with the MySQL, I tell the database I want to have this table with this information, and the rest is figured out by SQL, and it just provides me the information. and the template works the same way. I just tell it like, hey, this is the state I want to have, figure it out, right?
But yeah, I'm not sure if that example works that well, because with a SQL statement, for example, if you do create table, you cannot apply the same statement twice, because the second time will fail because the table already exists. The second time you need to do some alter
That's
table
true, yes.
something. So it's actually this is more like having a CLI bash script as a SQL script. It's a good question what it compares to, actually. So very good question. I don't actually know a good other example. No, I'm not. I can't think of anything that works in a similar way. So maybe could you say HTML is maybe a little bit like that, where you describe how everything should look like, and you're not telling. Maybe it's a good example. HTML and CSS is maybe a good example, because you're not telling your browser paint something here, paint something there. You just tell it, here's a table, it should be yellow, and the browser figures out how to do things. Maybe that's a good comparison.
That's a good one.
Yeah. Okay. And then maybe I want to quickly dive through. So how does it look like to work with CloudFormation? So when I use it, I still use it a lot. I was a very huge fan at the beginning. Over the past few years, so as with every tool, you learn a lot about the limitations. And one of the limitations of CloudFormation is that for some reason AWS is behind implementing all the new features and services for CloudFormation, because you need the tool to support all those different attributes, properties of the services. And so I was looking more into Terraform recently, but it doesn't matter. So how does it look to work with CloudFormation? So how do you define your target state? So with CloudFormation, you can do so by either writing a JSON file, which is you can do that, but probably a YAML file is more convenient because you have less syntax to write. And so the YAML file basically contains a few sections, and the most important one is the so-called resources section. And in the resources section, you just define the different resources that your infrastructure consists of. I give you a few examples. So an EC2 instance is, for example, a resource, or an S3 bucket is a resource, or what else did we discuss already? So a load balancer gets its own resource. Actually, it consists of multiple resources, like the load balancer and the target group and so on. So basically, those resources translate to the resources that are behind the APIs. So basically, you have another way to interact with the AWS API, because underneath, of course, CloudFormation is just calling the AWS APIs from all those services. So that's why if you know CloudFormation, you can more or less transfer your knowledge to Terraform or to the CDK, because the underlying API, the AWS API, is the same. So this abstraction on top of that is very close to the API typically. So that's why basically what you learn is you learn about the resources that the AWS API provides that you can interact with, the create, delete, update, and so on. So that's how that works. And then for each of those resources, you define the exact configuration. So you define, for a virtual machine, for example, you need to define the instance type, the AMI, the networking configuration, the IAM role, stuff like that. So all the details that we discussed in the last episode basically are available as properties for the resource, and you can, in a really fine granular way, define all those attributes for, in this example, the virtual machine, and for other resources, of course, as well. So yeah, and there is basically there is a documentation page that you go to where there's a list of all those properties for all those resources, and by using that you can figure out what do I need to get to put together, and that's basically like solving a puzzle. So I need this resource, but to create that I need another one, and then and so on and so on. And one important aspect is you can think of it as maybe as a variable, Stefan. So basically within the CloudFormation template, each resource gets a name. So think of it like a variable name. And with that, you can reference it within the template. And so you can now say, oh, this resource basically needs as an input something from the other resource. And by that, you are building those dependencies into the CloudFormation template, into the YAML file. So yes, really think of it like as using a variable and then using that variable to get attributes of that object on different places in the template. Does that make sense?
Yeah, it makes sense. 2 questions on the template. So first of all, thinking of a YAML file, especially with a lot of instant types and rules I have to be aware of, how names are called and so on. How is the error handling done in AWS? Is there an error handling, like, I don't know, I put my template in there and it tells me like, hey, this line is not correct? Or does it just tell me like, your template doesn't work and I have to figure it out by my own?
That's a very good question, Stefan. So yeah, the thing is, so CloudFormation is, as I said, it's a YAML file. So first of all, there is no types or stuff like that. So there's no way that gets compiled, or the editor, the IDE can check whether the thing that you're typing in is correct or not. So first, the answer is no. There is no syntax checking. But luckily, there is tools for that. So one that I use a lot is called CFN lint. So a linter for CloudFormation. And this is basically a tool that you can use. And I have installed that into Visual Code and the other IDEs that I'm using from time to time. And basically, whenever I make a change to my template, it checks in the background whether the syntax is valid. It doesn't cover all aspects, but it covers many of them. And it knows about the available properties. It even goes deeper in even checking some security-related stuff and so on. So it's a really good tool to help you writing a CloudFormation template. But it's maybe not what you are familiar with. So as a TypeScript, I don't know. Are you using TypeScript, Stefan?
I've used it, yes.
Okay. So there is that other approach. This is getting more and more popular, which is the CDK, which provides you. Think of it like a library that you can use for multiple programming language to write CloudFormation templates, basically. So in the end, this generates a CloudFormation template for you. And there is one available for TypeScript. And what that means is it basically generates TypeScript, how are they called, classes, or I don't know, type definitions, I think is the correct term. And it generates those for you, and that means when you type, when you program your infrastructure as code with the CDK, with TypeScript, then it's basically possible to kind of compile all that thing and basically notice errors right when you're typing it. So that's the typed version of CloudFormation, you could say. So that's, I would say, a very interesting approach. It's a lot faster because it's almost impossible to make a lot of mistakes. And there are some other benefits, but I would say that's a really important one. And so that's the answer to that question. So you had another one. Do you still remember the second question?
Yeah. Another one was can I, because imagining if I have a complex setup, that my CloudFormation template would become very, very chaotic at some point. So is it possible that I can reference one CloudFormation template with the other one, so that I'm basically have a generic template for spinning up an EC2 instance, and then another one which is just there to spin up, for example, an S3 bucket?
Wow, I love your question, Stefan. This is really, really good one. So yes, so totally. So when you start with CloudFormation for the first time, you notice that you get quite a long template with hundreds, thousands of lines defining your infrastructure, and then the question arises: is there a way to modularize my infrastructure as code setup?
Yeah.
So can I have some modules for, I don't know, the networking stuff, the application layer stuff, the database, maybe some stuff like that? And yes, so there are different approaches, unfortunately, to do so. So with CloudFormation, you have the option there are two options. One is called nested stacks. And you can think of it, so basically, instead of defining one template, you define multiple templates. And then you use another template to initialize the other templates. So basically, you have another one that just spins up the other templates. So that's one approach. The other approach that Michael and I are using with one of our GitHub projects, which is called AWS CF templates. There are different templates available that you can use to spin up stuff like, I don't know, the VPC with the networking configuration or a database. Those are just standalone templates that you can just start. But then there's something that is called exports. So think of it as a global variable in CloudFormation. And you can basically export values so that other stacks are able to read those informations. And so you can basically loosely couple multiple templates, multiple stacks with each other. So that's another approach. And for example, then when we talk about Terraform, which is the other tool, this has a very strong concept of modules, very cool one, very easy to use. There's a public library that you can easily use, or you can have your own private modules as well, stuff like that. And the CDK is really built with that in mind as well, with those module thinking. They call it constructs, higher level constructs. So with writing very little code, you can basically spin up a lot of infrastructure there. So yes, there are different ways to modularize your infrastructure as code.
That's great, because I, as a web developer and front-end developer, you do that anyway. So if you can do it in those templates as well, that's great.
yeah, absolutely. Yeah, very good question. Yeah, so let me think whether I forgot to mention something important about infrastructure. One thing I want to mention is, so we talked about how do you get into all of that. So how do you get started with AWS? And so I would say the natural way to get into those things is start with the management console, click around, play around, build examples, follow demos, all that stuff. And then check out the CLI to get a little bit more familiar with the underlying APIs. And then I think it's really important to make the next step and use, I don't mind CloudFormation, Terraform, or the CDK. I think that's the most obvious choice those days. And make use of those because it really simplifies the whole process, and it allows you to automate spinning up and managing your cloud infrastructure. And when I compare organizations, so there are a lot of organizations out there where they just click to the management console to spin up all their infrastructure. But when I compare those to those organizations that are really relying on infrastructure as code, there is a huge gap between those organizations, because you increase, first of all, the effectiveness of your engineers. So think about, you can just spin up another test environment from scratch within minutes without even without making any mistakes on the way. So that's a big important one. And the other one is it's getting more reliable to roll out changes, because what we do a lot is we have deployment pipelines, and they apply the infrastructure as code template from CloudFormation first to the test environment and then to the production environment. So in case there's something in there that might break or fail or something, we usually learn that before pushing it to production, or at least in many times we do learn so. And also it really gets possible to apply the same changes to multiple infrastructures in exact the same way. And that's especially important in case you are deploying your infrastructure not only in one region, not only into one of the data centers, but worldwide into multiple regions. And then that gets even more important, that you are automating the whole process really to the end. And that's why I think infrastructure as code with this declarative approach, this is really a game changer and a tool that everyone that works with AWS should get familiar with. Okay.
That really sounds like the. I guess it was hidden somewhere in your in your where it's used. But I could also imagine, like, without never working as a consultant, but using those CloudFormation templates to, I don't know if there's maybe cost-wise a better instance type for certain customers, that you just can change a CloudFormation template and roll that out to all of your customers, which is also very effective, I guess.
Mm-hmm. Yeah, totally. So that's a very common thing to do when you run a consulting business. You try to, so that's why we created those open source projects with our CloudFormation templates. Because whenever we work for a consulting client, we try to use those templates at least to get 80% of the job done, because most of the things are very similar in every project, right? And there are, of course, some details then often to some of the applications and infrastructures that you need, but we try to cover 80% with our open source templates, and then the 20% that differentiates the customer from others is then something we need to work on individually. But of course, yeah, that's another important issue. And also check out the open source community, because there are, for all those, for Terraform, CDK, and for CloudFormation, there are open source projects available that get you started, and you don't have to reinvent the wheel over and over again. So just use those things and get familiar with those projects. There are good examples there. Okay, so I think I would like to summarize what we discussed today. So I think the important thing to remember is AWS is all about APIs. So there is an API to control every service. There's an API to control every aspect of your cloud infrastructure. That enables you to automate managing your cloud infrastructure with the CLI or with an SDK, or what I would prefer with a declarative infrastructure as code tool like CloudFormation, Terraform, or the CDK. And this is really powerful, and I would really highly recommend to get into automating the things and not clicking through the management console, at least not for production systems. Okay. So this was another episode of the AWS-to-go series of the Cloudonaut podcast. So if you did learn something new by listening to this podcast episode, so I'd like to ask you for a favor. So please tell your friends and coworkers about Cloudonaut, and specifically this podcast episodes. Also leave a review, leave a rating of what we do. And our work on cloudonaut is possible only because of your support. So therefore, we want to thank all of our supporters, because with your help, we can continue to produce independent and high-quality content focused on AWS. And if you're not already doing so, please consider supporting us with a one-time or recurring donation. You will find all the details in the video description and the show notes. So thanks for listening, and we'll be back soon, Stefan, right? With another episode of AWS-to-go.
Yeah, for sure.
Very cool. So bye.